yeah, I guess you can also apply this to email, but the problem is there are many ways for you to receive the email. Sometimes you can receive the email over web interface. So the problem there is really essentially that email that's going to be part of your file system causing the damages, rather than so basically for all the file-based problems like viruses, the best solution is really the antivirus software.
So just to understand.
Yes.
Going back to your previous answer, actually.
Okay.
When you're talking about the email ones, actually the problem there I hear is that because the Outlook actually is configured automatically to open the attachments. So, I mean, if it is similarly, if you look at the code red, the problem came because XP actually automatically had this web server installed and people didn't know, right?
Right. So yeah, you can use Shield for that. So I think later on, that problem is fixed because by default you don't do the preview of your emails. But if that's misconfigured, you can still use Shield to trace on your SMTP protocol and possibly inspect the email content. It's possible to do that.
Okay, another question.
Sure.
You talk about actually the traffic being encrypted, right?
Yeah.
So do you think there is any attack currently that actually uses encrypted traffic?
So basically, for end-to-end application-specific encryption, if we can get a private key in Shield, of course we can do something about it, and also it may not be inefficient to do that in Shield. However, it's probably not reasonable for Shield to obtain the private key for a particular application. In any case, for application-specific encrypted traffic, it's very hard to deal with. So I think there is always inherent tension between the security and privacy. The tension here is you want to encrypt your traffic to have your privacy. However, when you encrypt the traffic, it's not possible for third parties to inspect in it. Another answer to this question is, for infrastructure-based end-to-end encrypted traffic, I believe we can address. Basically, we can say we can lift the Shield at a layer of the for example, above SSL, so that Shield will have the access to the encrypted payload, decrypted payload, to inspect the traffic. Yes.
You mentioned early on that there was one of the main problems with worms was that users just don't patch their systems. What kind of distribution network do you envision for Shield?
Right. So the kind of distribution we have in mind is to basically have like an antivirus-based kind of distribution model. How antivirus works is that whenever there's a new virus discovered, the virus signature will be distributed to every end host. Or there's an agent running on your system periodically polling for the new virus signatures. So this can be done similarly for Shield. Basically, we periodically distribute. Basically, whenever there's a new vulnerability, then there's a vulnerability signature authored. Then that vulnerability signature will be automatically distributed to everybody. At that point, you're protected. Yeah, so it is automatic in that sense because of the data-driven feature of the Shield system.
So to steal my question, Ryan. Sorry. Any other questions? Okay, let's take a couple more.
Good. So I guess the goal is just to be outside of just Microsoft, right, in the future, to have like other vendors to also provide Shield things, or is it just Microsoft specific?
So this mechanism is good for everybody, really.
But it seems to require that vendors give up their protocol. Then, I mean, if people want to do this, they have to give up their protocol state table, which they made.
Yes,
kind of
we're required to do that anyways, don't we? And yeah, third parties, they can, right, that's true. It may pose a problem in certain scenarios, other non-technical problems in some scenarios.
So, like in implementation, does it mean that when in the state machine it's executing in some function, essentially, then you are going to say that, yeah, there may be an exploit. Like, for example, V4, does it, at a higher level, does it really mean that if it's executing in some part of the code in of the application.
Right. So all we're doing here is basically we don't want to be so entangled with the application at the code level, at the executable level, or we want to be completely not in the process of the application. But rather, at the network level, we just want to passively observe the message that are passing by between the application from this host with some remote entity. And through this process, we figure out exactly, where you are in this protocol state machine. For sure that that application is executing some code, but we actually don't want to have that detailed knowledge. We want to be as separate from the application as possible. And that actually gives us, that's the reason why we have this edge of being easily deployable. Because we're at the network level, we're doing data-driven. We're just looking at the messages and to see which part of the message causes the problem.
Is it really at the network level? Because you are just, the shield is executed, the layer, protocol layer that you showed, it was at the user level and it was just below the application between the socket layer and the...
Yeah, being at the network level meaning that I look at the network messages and being at a separate process. It's actually not really the separate... So our specific implementation is in the LSP. You can think of this as being part of a kernel, right? So being part of the network stack, whenever there is a send call that's being called, then there is a callback into the shield logic to do the deep inspection. That's exactly how some of the firewalls are implemented.
I'm trying to compare it with the host-based intrusion detection system, and how does it?
Host-based intrusion detection, there are many ways of doing that. Some ways is to use the system call sequence. And you can also do some sandboxing kind of schemes. It's essentially similar to some of those schemes. We're also intercepting. You can consider us intercepting the system calls.
Or just do whatever you do at the network level, at the host level, like look at the packets.
That's what we do. That's the mechanism how we carry this out.
Do we have time for more? Should we leave now? Well, let's. We can talk to Dr. Wang now offline, and I guess we need to vacate this room for the next class, fortunately. So thanks. Let's thank Helen for the wonderful.
Thank you very much.